Hi everyone. In this lecture, I'm going to talk about Oracle GoldenGate architecture. By the end of this lecture, you should be able to list and describe the processes in Oracle GoldenGate, explain the initial load and change synchronization mechanism, explain checkpoint mechanism in Oracle GoldenGate, describe CSN, and describe the purpose of GGSCI utility. Here you have a list of the GoldenGate components. We have the manager process. This process is used to start and stop the other processes, but it's not required for the ongoing operation of the other processes. For example, you use the manager process to start an extract process. After that, if you shut down the manager process, the extract process will not get affected. The extract process reads from the source database transaction log files and stores the committed transactions in GoldenGate specific files called extract trail, or you can call it trail for simplicity. Sometimes the extract process is called the change data capture process or capture process. You can configure a secondary extract process that's called data pump extract or data pump. The data pump process is also considered as an extract process, but it is a special type of extract process. The data pump process does not read from the database transaction log files. It reads the data from the extract trail files and sends them over the network to the target database system. Configuring the data pump process is optional, but it's highly recommended. I have never seen a GoldenGate production system where the data pump process was not configured. So typically, you would have two extracts in the source database. One is the primary extract, which reads from the database transaction log files, and the other one is the data pump, which reads from the extract trail files and sends the data to the target system. We also have the server collector process, and for the sake of simplicity, we call it the collector. This process operates in the target system. All what it's doing is communicating with the data pump process to receive the data from it and saves the data in files called the trails. Usually, you never control this process. It starts up and does its operation automatically. We have another process that operates in the target system. That is the replicate process. This mandatory process reads from the trail and apply the transactions on the target database. Again, this process has a different name. Sometimes it's called delivery process. In GoldenGate, we have extract files, or the trails. Extract files are created by the extract process, and they contain the committed transactions read by the extract process from the source database. We also have the remote trail files. Those files also have committed transactions, but they are created by the collector process in the target system. Checkpoints are data stored by every GoldenGate process to save its operation progress. We will talk in more details later in this lecture about checkpointing in Oracle GoldenGate. Wallet is used to save the user IDs and their passwords. We will cover this component in a future lecture. Now, let's see how those components and files interact during normal GoldenGate operation. When you implement any replication solution, you usually start with making a copy of the source database into the target database. In Oracle GoldenGate, this process is called instantiating the source database. Of course, every RDBMS vendor has its own tools to copy the data from one database to another. In Oracle database, for example, you have the data pump, you have the SQL loader and the external tables to copy the data across the databases. In GoldenGate, you can definitely use those tools to copy the initial state of the dataset from the source database to the target database. But in addition to those options, GoldenGate provides its own tool to make a copy of the source dataset to the target system. If you use GoldenGate to instantiate your dataset, GoldenGate refers to this process as initial load. An initial load takes a copy of the entire source dataset and applies it to the target tables so that the movement of transaction data begins from a synchronized state. I will explain over here how the initial load works in GoldenGate. In this diagram, we have a source database where GoldenGate is installed in it, and we have a target database where GoldenGate is also installed in it. Those two databases are connected to each other through an IP network. In the source database, you have a group of tables that you want to replicate to the target database. When you kick off the initial load process in GoldenGate, a special type of extract called initial load extract will start, and it will read the data from the source dataset and send them through the network to the target database. In the target database side, there will be a special type of replicate process called initial load replicate. That process receives the data stream from the source host and saves the data into the target database. The operation continues till the whole data is fully copied. The replicate process have 4 possible methods to load the data into the target database. We will discuss about those methods in a separate lecture. This option of loading the initial state of your source dataset is fine for small to medium-sized tables, but for large objects it can take very long time to finish. However, if the source database and the target database are of different vendors, sometimes it is difficult to make the data copy using the database tools. In such scenarios, GoldenGate could be the best solution for you. After you perform the initial load, GoldenGate should take care of synchronizing the changes made on the data in the source database to the target database. This is an ongoing process, and it is called online change synchronization. It keeps happening as far as the system is up and running. In this diagram, I will explain how GoldenGate process cooperate together to perform this change synchronization. In the source database side, you would have the manager, extract, and data pump processes running. In the target database, you would have the manager, collector, and the replicate processes running. The extract process reads the committed transactions from the transaction log file in the source database. It writes the data to a local GoldenGate trail files. This file is also called extract files. The data pump process reads the trail file and sends the data across the network to the target system. On the target system, a server collector process reassembles and writes the data to remote trail files. A replicate process reads the trail and applies the data to the target database. And that's it. It is as simple as that. In summary, you've got an extract process which reads from the transaction log file and sends the data across the network to the target database. In the target database side, you've got a replicate process which applies the changes to the target database. As I said earlier, the data pump process is technically optional. You can have the extract process to send the data straight away from the source database to the target database. But in a production system, this is not practical, and I don't recommend you to do that. Also observe that the manager process has no effect in this process. We only use it to start, stop, or monitor the other processes. Final comment over here. The extract and replicate processes that you used in the initial load are not the same as the extract and replicate processes that you use for change synchronization. You configure each pair separately. When you configure the GoldenGate processes, you define them in a process group. A process group consists of a process, either an extract or replicate, its parameter file, its checkpoint file, and any other files associated with the process, such as report, discard, and column definitions ASCII files. Extract and replicate processes may run in classical or integrated modes. Integrated mode is only available with Oracle databases, and we will discuss the difference between the classic and integrated modes in a lecture dedicated to that subject. For a replicate process, a group may also include a checkpoint table if you have configured one for it. When you give names to the process groups, you can use any OS-supported naming convention you want. The slide is showing a suggestion naming conventions. The first letter of the process name indicates the process type. Extract E, initial load I, data pump P, and R for the replicate. After that, you indicate the application type, for example, HR for human resources, PRL for payroll, and so on. Finally, you set the host name. I will show you some examples in the next slide. In this configuration, we have two servers, SRV1 and SRV2. On the SRV1 side, we have an extract process called EHR SRV1 and a data pump process called BHR SRV1. On the SRV2 side, we have a replicate process called RHR SRV2 and extract process named as EHR SRV2 and a data pump process with the name PHR SRV2. You are free to grab the naming convention that suits you. The naming convention in this slide is just an example. Parameter files are ASCII files, where you set the values of specific parameters in them. Those parameters control the functionality of the GoldenGate processes. You have two types of parameter files, global and runtime parameter. The global parameter files controls the GoldenGate instance as a whole, whereas the runtime parameter controls the functionality of a specific process. Runtime parameter file usually takes the extension PRM. GoldenGate saves the parameter files in a subdirectory called dir PRM. Every GoldenGate process has its own checkpoint file. Checkpoints are used during online change synchronization to store the current read and write position of a process. In this slide, I will explain how the checkpoint mechanism is working in Oracle GoldenGate. When the GoldenGate is in operation, you've got the extract process reading from the transaction log file of the source database. In the example shown in the slide, the transaction log files has 4 transactions. Transactions 2 and 3 are committed, but transactions 1 and 4 are not yet. As a result, the extract process will read all the commands of transaction number 2 and saves them in the extract file. For an extract process, the checkpoint is its positions in the data source and in the trail. This is fair enough for the extract process to know where to start its operation after a system failure. The process proceeds with its operation and saves transaction number 3 in its trail files or extract files. Again, it issues a checkpoint and saves its information in the checkpoint file. The data pump process does a similar job. It reads from the extract files and sends the data to the target database. It issues a checkpoint and saves it in a checkpoint file. Again, the checkpoint information represents the process reading and writing positions. The replicate reads from the trail file in the target database. And the same way, it issues a checkpoint and saves it in its checkpoint file. In summary, the reading and writing positions of every process are saved in their checkpoint files. A commit sequence number, or CSN, is an identifier that Oracle GoldenGate makes to identify a source transaction. The CSN is used by the GoldenGate for maintaining transactional consistency and data integrity. Trails are the files used by GoldenGate to save the changes in the source database. They can be created in the source or target system, or even in an intermediate system. Only one extract process can write to the trail file. They can be read by the data pump or a replicate. By default, the trail files are saved in a directory called dir.dat subdirectory under the GoldenGate root directory. In some configurations, Oracle GoldenGate stores extracted data in what is called extract file instead of an extract trail. In fact, extract files are so similar to the extract trail, except that checkpoints are not recorded in the extract files. GoldenGate Software Command Interface, or GGSCI, is a command prompt utility that you use to issue the commands to configure, control, and monitor Oracle GoldenGate. This utility allows you to type the commands or run them from a script file. The script that you may create for GGSCI may include a mix of GoldenGate commands and operating system shell commands. We will use this command interface in almost all our practices in this course. So that's it for this lecture. You should have learned how to list and describe the processes in GoldenGate, explain the initial load and the change synchronization mechanism, explain Oracle GoldenGate process group, explain checkpoint mechanism in GoldenGate, describe SCN, and finally describe the purpose of GGSCI. In the next lecture, you will learn on how to install Oracle GoldenGate. Till seeing you over there, thank you very much.